There we go. Hi, folks. Welcome to
Hello, everybody.
Installing Infinite Postgres on Kubernetes.
I'm not quite sure if you can see Dave. Oh, Dave, here you go.
Well, I'm going to drop off quickly and hand it over to the Postgres Person of the Week last week. We couldn't get him online, that thing. And I will drop off. And folks, this is a great thing. You're going to learn a lot today, as will I. So with that, here is Charly.
All right. So, yeah, we're having some technical difficulties here. I cannot see or hear Dave. So, and probably going to be just myself today, so on the stage here. And the talk today, it was to be about Kubernetes and containers and the database and all this kind of stuff. And I was thinking on what to discuss about those things. And now that we have these difficulties, these technical difficulties, so we need to do some improvising, to improvise a little bit here. And one thing that I was thinking is we need to understand the underlying technology when we start using them, right? So, for example, when we talk about Kubernetes, so the first thing that comes to mind are containers, right? So things running inside of containers, and then you have the whole ecosystem of the Kubernetes it's going to do the orchestration and all this kind of stuff. And people are talking about container for quite a long time now. So 5, 7, 10 years, I don't really remember when this hype started. But it's been quite a long time. But one thing that I've seen is a lot of people, they still do not understand what is a container, especially on the Linux environment. When we talk about container inside of Linux, a lot of people, they think a container is a lightweight virtual machine, which is not quite true. So it's a good way to explain, but that's not exactly how it is. And before we start to talking about Kubernetes, or before we start to trying to run Postgres inside of the Kubernetes, we need to sort of have a better understanding what is a container, right? And this is one thing that I will try to do today. So we'll try to build together here a container environment without a container ecosystem. So we're going to build our container without using Docker, LXC, or whatever other container environment. It's going to be a Postman container that we're going to build today. So I hope that works. We've been doing some tests here, and a lot of those tests, sometimes they don't work quite as expected. Sometimes they fail, but it's been quite fun. And I believe that this is a really good way of learning when we have the failures, and then we need to understand what was broken, what failed, and this is the way that we can understand. And the main objective today is to have 2 containers inside in a box. So I have a virtual machine on AWS. So I have a box on AWS. And then we're going to build 2 containers. They're not really containers. But it will give an idea how things work underneath. What are the technology that's being used, and how those things work to give us this idea. So let's start sharing my screen here. Just a second. Okay, this is my screen here. I hope everybody can see well. So I increased the font size here. If you can see properly, or if you have anything, you can give a thumbs up. So Dave I cannot hear or see Dave, but like he's there, so he can ping me and let me know if you guys can see or cannot see. Okay, so as I said, I have this virtual machine here. So let me connect. I'm using here Visual Studio Code. There is nothing no plugins, nothing here on the Visual Studio Code. The only thing that I'm doing here is to use the terminal here underneath. I have the terminal here under the window, and we have I have some most of the things we're going to do. I've scripted here, and I'm going to go through each of them so we understand what I'm doing here, and we understand how those things work, right? So this is just a normal Linux box. There is nothing here. So for example, I'm using Amazon Linux. So I can do a rpm-qa search for Docker. Not search, it's grep. Grep Docker. So there's no Docker installed. There's no LXC. Nothing here is being installed if I try to run Docker. So command not found. So we don't have any container environment installed here on this machine, right? But one thing that I did in advance, I used my laptop to download the one Docker image. Actually, this image, we will see it's just the file system of the image. So I could have been created using the one of Ubuntu or Debian, which is the image that I'm using here, and install and then copy the files, but that would be, it will take quite a long time. And the easiest way to get the image working, the file system working, is just using something like Docker or like CA, just pull. We'll see that there is nothing fancy here. It's just literally the installation of the system, just the file system, right? So let me do a sudo here. I'm gonna use the screen. I like to use the screen here because it can have multiple terminals. And we'll need multiple terminals for this example. You'll see later on. So the first thing that I'm gonna do is I'm gonna create my file system hierarchy, right? So it's just create. I'm lazy, don't like to type. I could have like just mkd lab containers, nodes, blah, blah, blah. So, but I'm too lazy to do so. Instead, so I just created those files. So, and we can check here on those files. So I have one folder that's gonna hold all the containers we create, and one folder that will hold all the images. So the image that I downloaded previously. So there are tar files, right? So, but now they're empty, right? I just created, so we can remove and create again. Just make sure they're empty. Okay. So yeah. We're gonna have two nodes. Remember, the objective is to have one primary and one replica. They've been replicated. They need to be able to communicate between them. And we use a totally different network addresses here instead of use the same address family of the box that we're using instead of using the server here. But we'll see. So if I check node 1, so we'll see that we have two different folders here. So this is when things start getting interesting. One thing that Docker does is to use the overlay file system mounting point. So, and how does it work? When we mount using the overlay mount here, we can simulate what we have, for example, on Git. We have different layers, one on top of the other ones. In the example that we're going to use here, we're going to use basically 2 or 3 layers. So we're going to use the lower layer, right, that we have here. We're going to use the lower layer. So the lower layer will be where we're going to put the basic installation of the operational system. So everything that I'm going to copy from this image here, I'm going to put inside of this lower layer, right? And then I'll tell the overlay that, look, this path, I have the lower layer. When you mount it, just use as the lower dir for the layer. So we won't be able to change anything on this folder anymore. It will be frozen. It's like, okay, we did it mounted here, and everything now is frozen. And I'll tell the overlay that, okay, now you also have an upper layer, an upper dir, that is this upper one here. This is where all the things where you start doing gonna be saved. For example, if I create a new file, the new file gonna be saved here. If I change a file that exists on my lower layer, what it does is it copies the file and saves with the change inside of the upper layer. So it means that every time that we change something inside of a Docker container or an LXC container, we are replicating the files, right? That's why people tell you, if you have something or if your application changes files inside of the container, instead of using the container file system, create an external mounting point and mount inside of the container. Because it will always be replicated. We have multiple versions of the same file. And we have this merge one. So this merge here is what's gonna give us the idea of the final file system. So it will get the lower layer, it will get the upper, the work layers, all the layers, it will merge and just expose to the container the latest version of the files that we have. Okay, that's too much talk. Let's start building those things. So I'm gonna execute here. If you see here, what I did, I changed my keyboard shortcuts here. When I press Control Alt Enter, it just executes the line that I have here. So, but you can see the execution now here. We can follow the execution now here. All right. So I here moving the tab files inside of this lab, so we can check if everything is in there. So it's indeed that we removed. So I have two images here. One is for Debian and another one for CentOS. So for this example today, we're gonna use the Debian one. So right, I'm gonna decompress here inside of a folder that I called layer. Funny thing is, if we check what's inside of this folder here, we see that it created a directory with a Docker UID. So this is from Docker. And inside of this guy here, let me just copy here. We'll see there is another tar file, a layer.tar file. And this is the file that we have all the file system, the Debian file system, the etc root / bin, all the file system is inside here on this tar file. So, and what I'm gonna do now, I'm gonna decompress this file, and I'm gonna put inside of our lower layer. So this is what we're gonna do here. We're gonna untap and put everything inside of the lower layer. If we check now the lower layer, so we'll see that it should be empty. Oops. See, it's empty here. There is nothing in there. And when we decompress here, now we have the file system. So this is basically our Linux file system. In my case, a Debian that I just downloaded from the Docker file. So now we have a base mounting point for the file system, right? So what I'm gonna do is I'm gonna mount this using the overlay. I'm gonna use again the lower layer. So we're also gonna use the upper. Let's check what we have inside of them. So here should be empty. Yeah, it's empty. And the work one is also empty. So it's also empty. And the one that we care is the merge one, right? It's also empty. One thing is, for this one here, I'm naming it. I'm just calling none. And okay, and I mounted here, and the mount, so yeah, the mounting point that I called none was mounted on this path. This is the path that is mounted. Exactly the path of the merged one. So if we check the merge now, oops, we'll see that we have the whole file system here, right? And those are exactly the files that we decompressed here, and they're inside of the lower layer. We work, we install the Postgres, we do everything, but everything from now on that we do inside of this container will be not saved on the lower layer anymore. Will be saved on the upper layers, and it can create more and more layers. So we can have a whole history of all the changes that we do inside of the file system, right? So, okay, I mounted here. And now it's time to understand the next important piece of technology, let's call it this way, that is enable a container to work, which is the namespace. Namespace, in a very naive way to explain, a namespace is a way that the Linux has to isolate information from not only users, but for process itself. So we have basically, if I remember correctly, we have basically 7 different namespaces. We have the network namespace, so we can create isolated networks. And we have the user namespace. On the user namespace, we can have, as the name says, we can have the user process and users itself isolated inside of each namespace. We have the UID namespace. We have the UID namespace. We have, let me see if the PID namespace, sorry, not UID. We have the PID namespace. This is also very important for us because when we start running our container here, we don't want the PID that's inside of our container to be the same PID that is outside of the containers on the Linux box. So we want our application to believe that it's inside of a Linux machine and it holds everything in there. And the PID namespace is going to help us to isolate all those things. Right? And there are other namespaces for now that we basically care about those 3. And what I'm going to do here, the first thing is I'm going to start creating our network topology. And to create our network topology, I'm going to create in a different namespace. When we start Linux, the machine, we start the machine for the first time, you are already inside in one namespace. This is the original namespace. There is a technical name that I don't recall now, but this is the main, let's call main namespace. And everything is in that main namespace. And the owner of that main namespace is the process 0, or in the case, the first one that booted the system. So the root is the owner, and the process 0 or process 1. I guess it's process 1. Yeah, the process 1 is the owner of the full namespace. So everything that we do with like the shell that we have here, everything that I've been doing here are in this original or main namespace, right? If I create a network interface here, I can use the IP command here to create a network interface. If I just create a network, it will be created in this main namespace. And because it's in the main namespace, so it has a lot of restrictions, right? You need to be a super user to do everything here, all those kind of things are restrictions because we're inside of this main namespace. So what we're going to start to do now, we're going to create our own namespace, and everything on that namespace will be isolated from the main namespace. So everyone that is being here won't be able to view or to see everything. Well, there are techniques that we can use, but like it will simulate what we really is a container, right? So here I'm going to create a network. It's just adding a network namespace. This is what it does. So, well, this is wrong. It's here, just add the network namespace. And I'm calling this network namespace ND1. So this is what I do here. We create the network namespace. And then what I'm going to do is I'm going to create a bridge, right? Because remember that I said we want to use a different network topology inside of our containers. Like for example, here my box has the IP 10.0.100.12. So this is the network family that we have here, not family. The network mask that we have here, we are on the network 10.0.100. And what I'm gonna do here, I want to put everything on the network 192.168.22. So for them to be able to communicate, and for our container to be able to communicate to the outside world, we need a bridge network. It looks like it's gonna work just like a switch or router. Actually, a router is a bad idea, not a switch. It's a router. So our network, our container will be connected, not physically, but will be logically connected, and I will show later how that works, to this router. And this router will route everything to outside of the container. And also, when we communicate from outside to the database inside of the container, we need to have a way to route to that namespace. And the bridge, as the name says, it's going to be the bridge between the container and everything outside of the container. So let me create this bridge. Okay, I'm going to assign an IP. This here, I'm going to assign the IP for the bridge. And oops, this is our bridge IP. And I will just enable it, right? So the IP up. If I go here again, IP-A, now you see that we have this new network interface. We have a bridge here. And this bridge has exactly the IP that I just gave to it, right? So this is the IP that we have. And it's up. We see the link. Yeah, we see here the link. Yep, it's up. Here, it's up. So it's working so far, so good. And another thing that we need to do is we need to tell the kernel that we want to enable the package file forward. But what happened is, now our box is working as a router, right? So, but usually, when the kernel, the network interface, like the HE0 in this case that we have here, receives a package that is not addressed to this network interface, it will just drop. It won't do anything because it's not addressed to this network interface. We're telling here, so look, man, we're working as a router here. So before you drop anything, can you check if it's not addressed for one of the IP or the network families that you know here? So then you can forward that information, that package. If you don't do this, it won't forward, and our container will be fully isolated. It won't be able to communicate to outside or receive anything from outside. So we need to tell the kernel that we want to enable the IP forward. And here, there are other ways to make this, but here for simplicity, I'm using IP tables to forward all the package that comes from outside, looking for this network address to send them to our bridge network. It's just helping the forward things. Okay, now we started our network namespace, right? So far we have the bridge. And what I'm going to do now here, I'm going to create 2 other namespaces. Remember, we have the network namespace, but now I want the PID namespace. And because we want to be isolated, we don't want to the outside world to see what's happening inside. Well, they can, but not with the same ID. And more important, we don't want our applications inside of the container to see what happens outside of the container. We want really them to be isolated. So, and I'm going to use the network namespace that we created. I'm going to use the merge folder. So I'm also doing a Cgroup here. So it will tell now that we are just mounting, changing the root folder. It's kind of who works with Debian has something similar that was they call fake root. So the idea, the concept, the idea is very similar. We are literally creating a sandbox here. So this is a sandbox. Everything will be encapsulated there, including the file system, which is the file system that we extracted previously. Okay. So if everything worked fine, now we are inside of the container, and we can check here, for example, the PS. Oops, yeah. This is one thing of image like Debian or small image that we download from Docker. They don't have anything, right? PS, for example, they don't have the command PS, right? Okay, that's fine. I want to change the host name because the outside, the host server is SRV. I want to be able to know. And one thing that it was not able to show you is because we don't have PS here, is we need to mount the proc file system. The proc file system it's a virtual file system. It's not a real file system. It's in memory. It's controlled by Linux. It's everything that is there. It's something that the kernel did, and the information that the kernel needs to keep and use for a lot of stuff. And when we created those things here, the container. I have ls here. Yeah, I have ls. So if I check the proc, we'll see that's empty, because when I use the Cgroup here, I just told the kernel, look, I want to change my root folder. So from now on, my root folder, my operational system is on this path, that is the merged one. So this is my root file system. But I didn't tell him that I also want to be able to have my own proc file system here. So when the proc file system is where we have the UID, the PID, all this kind of stuff, they reside inside of the proc. So we need to mount it. And yeah, now that I mounted it, so if we check, now we have a lot of stuff here inside of the proc file system. And if you see here, we have only 2 PIDs running inside of our container. The PID 1, that's the original one, the first one, and the PID 9. So if I go to the outside, so I'm here on my server, on my host. If we check, oops, we have tons of PIDs here. All of those are PIDs. So they will be related to all those PIDs that we have here, right? So all of those numbers are the PIDs that we see when we run the PS. Okay. So let's go back. I want to show the names of the host here, and the easiest way to do is just sudo again. So you just reload the information from the variables. That's okay. So now I need to finish my network configuration. And to finish my network configuration, I need to do those things on my host. I cannot do here inside of my container because they do not exist and they are related to the host. For example, if I try to run here, you see that the command doesn't exist because I'm inside of my host. I'm inside of my container, not of my host. So I'm now going to my host. So, and one thing that we need to do is we need to create a with network or a with pair. What we call a with pair is a pipe. It works like a pipe. It's like the cable that you plug on your computer to the router or to the switch. This is the cable that we're gonna plug from the container to the bridge, right? And it literally works just like a pipe that's gonna link the container to the bridge network. And as it is a pipe or a cable, it has two ends. One end we're gonna plug on the bridge, and another end we need to put on your computer, right? If you're using a physical cable, and this is the same. We're gonna have two ends, and that's why it's a pair. And one I gave two names. One of the names is this. That is the one that we're going to plug on the container, and this is the one that I'm going to plug on the bridge. But it's just name. The name here we just pick a name, and can be whatever name you want to give to them. Right. So remember, when we create things using IP, it goes to the main namespace, right? But we want to move it inside of our namespace. Remember that the name of namespace I created was MD1880. So yeah, I'm gonna move this with inside of that namespace. So okay, I'm gonna move, and then I'm gonna plug one of the points. This I'm setting the master of this to the bridge. So one of the ends, one of the points of my cable, I'm just plugging here on our bridge, on our switch, right? And I'm gonna set it up. So, but before, if we check here, we'll see that it's already exists here. It's already created here. It's already linked to the bridge, but it's down. See, the state is down. So we need to put it up. And if we check now, and here we go. It's up now. So this is what we just created. We created another network interface that works like a cable that we plug from our computer to the switch. That's fine. Now we need to work on the other end. This is the end that we're gonna plug inside of the container, right? So the first thing that I'm gonna do is I'm gonna give it an address. So, but the funny thing is, if we check here, we won't see this address. See, there is no, the address that I gave is 22 and 2. I only see the address of our bridge. Because remember, this one is inside of our container. This is not outside anymore. So I'm gonna put it up, and now, this is the loopback interface. So we also set in the loopback interface, and I put this loopback interface, and this loopback interface is inside of our container. See, the IP-n here means that I'm working inside of a namespace. It's just like the IPNS. They're the same thing. The -n is the short one for NSDS. And here is the name of the namespace. Remember that we gave this ND1 at Europe. So I'm running those commands inside of this namespace, right? So inside of this namespace, I'm setting up my loopback interface. Now I'll set up my physical interface. This is the interface that you're gonna use, and this is the interface that holds this IP now, because this is where we gave it here, right? And one last thing that we need to do is we need to set a routing table. So for example, if I execute this, let me get a copy here. I'm too lazy to type. So if I execute, actually this is the one I wanted to call. If I execute here, the command IPA, this is inside of our namespace, right? So, oops. Execute. Of course, I need to give the namespace name. I need to name it. So this is what we have inside of our namespace at the moment. So we have our loopback interface and we have our network interface. See, the address that we gave to our network interface, this is inside of our container. Literally, this is already inside of our container. This is not on the host anymore. This is exactly what it shows when you run your doc exec or docker run or something. This is how it translates inside of the kernel for commands that we do on the Linux, not the kernel, inside here on the Linux, that we're using bash commands. And I need to have a routing table. So if we use IP-RR, you see that our routing table here it's empty. Actually, it's pointing to its own IP. So I'm adding a default route, and the default route I'm pointing to the bridge address. Remember the bridge? Everything that goes from here to outside goes through the bridge. So at the moment, I cannot ping anything from inside here. If I try to ping like this address, if I try to ping the Google address, so I just get network unreachable because we don't have routing. Now, after I add my routing table, so I can come back here, and now we can be routed to outside. Now we have access to outside because we have access through the bridge. The bridge network is giving us the access to outside here. So at this point, we're basically done with our network inside of the container. So what we have now at the container, we have the file system, we have the PIDs, and we have the network, right? We basically have everything that we need. And now it comes to the latest one that I want to talk today, that are the Cgroups. So if we just leave the container like it is now, we can use. The problem is this container can exhaust all the resources that we have. And Cgroups is what we use to control the resources. So the Cgroups, we put some limits to the resource. Here I'm going to, well, this is just to finish the networking things here. So here I want to put some limits on the memory. I don't want my container to use more than 1 GB. So what happens is, if my container or whatever is inside of my container, for example, if my database is inside of the container, try to use more than 1 GB, here the kernel will kill it. You'll see a OM kill, and will kill that one because it's the container using more memory than it has. So I'm given how much memory my container gonna have here. And we can limit everything. We can limit memory, we can limit IO, we can limit CPU, we can limit network bandwidth. So most of the things that we can limit using Cgroups. So I want the swapness to be 0 because I don't want to have swap inside of my container. Here I'm just binding those informations to the PID, because remember that I said when we start the Linux box, the first PID, the PID1, is the PID that is the owner of that namespace, right? Here, this bin bash that I executed when I mounted here, when I executed the unshare and I forked here, this bin bash is the owner of our namespace, is the owner of our container. This is the guy that is running our container. So this guy has the PID1. For example, if not yet, but I will show soon, because I'm going to install some stuff inside of the data, inside of that container, right? And what we do here is we are telling that everything that is related to those PID, that everything that's inside of our container are exactly in the same group. This is what we're telling here, because everything that we execute now will fork from that PID, because it's inside of our container. So you will be under the same fork of the PID or that created our container. So I'm telling to the Cgroup, look, all those guys are in the same family. All those tasks, everything that happened here are in the same family. So I want you to control the family, not only one PID. So if the family exceeds 1 GB memory, it will kill my container. This is what we do here. So now I'm done with my container. Out from outside, all the configuration that I needed to do on the host. Now I can go back to my container. So I can go here. Now we're inside the container. Remember the note one thing here. We are inside the container. And now we can start working. So I'm going to do a apt update. And look, let's recap. I'm running on a Amazon Linux. Amazon Linux, oops, Amazon Linux here, we don't have apt, right? Because it uses yum. So that's the first thing that we need to keep in mind. We are running, oops, not this one here. Okay, we are running already inside of the container. We are running Debian commands here inside of our container. So I want to install Vim and some proc stuff. Those proc stuff are the ones that are going to give me the PS. So finally we have PS here. We have some stuff inside our container. And see, we have few PIDs here. And this is the PID one, the first one that we created, that first bash is the owner of everything, right? I'm going to install Postgres. Okay, install. Should take just a few seconds here. Not install Postgres. One thing that I really, well, it's just preference. I don't like the way how Debian works for Postgres, is because it puts all the configuration files inside of etc. And sometimes it gives me some troubles. So what I'm going to do here is I'm going to copy the postgres.conf file and the pjba.conf file inside of this folder, because if you see here, we don't have them. We have postgres.auto.conf, but you don't have the conf and that pjba. So I'm copying and I'm using some configuration. For example, I'm changing the location of the GB file instead of the postgres.conf. The listing address I'm putting to star instead of localhost. The log destination, I'm enabling logging here. So the log collector directory I'm putting to the dash log. The file name instead of that huge file name, I just want all my logs to be just postgres.log. That's it. So I want to have the truncate on rotation. It's usually not good to have truncation on rotation, but here I don't want to keep too much logs. I want it to truncate to 10 megabytes, so it doesn't matter how it does. And I want to disable the include D that is inside of the postgres.conf, because it always gives trouble. And on the PGA I want to allow connections for everywhere, right? And this is all inside of the container, right? So we could have done this. I could have saved the configuration file and then just put the configuration file here. And so it's easy to do here. And now it comes to the time that we start the database, right? So, well, that's fine. It's because I'm running the SU Postgres here, but it started the database. And how can we double check? Well, we have a Postgres shell here. We have a Postgres database working now, right? So I'm gonna create a user, Charly. I'm gonna create a database named test. I'm gonna change to that database. I'm gonna create a table, and I'm gonna insert a lot of things. Yeah, I inserted 1,000 rows. So that's fine. That looks amazing. We're running inside of the container, and we see that from inside of the container it works. But are we able to access from outside? Can we access this container from outside? Let's try it out, right? So, oops, not here. So what I'm gonna do here is I'm gonna try to do a PSQL. So remember, this is the IP that we gave. So, and well, PSQL not found. Yeah, of course, I'm inside of my host now. So, and on my host, I need to run the yum install. So I just install the client. I don't need everything, I just need the client. And what if now we try to access? Well, that's a good sign because it's asking for the password. If I type the password, and here again, I'm accessing my container from outside, from the host. So all those network things, they worked. And now I have a Postgres running inside of a container that I built without using LXC or Docker or anything. We built it manually, we built it by hand. This is my poor man's container, right? So I can do a select count stuff from, what's the name of the which one? Yeah, we have 1 million rows here. So it's working fine. So now the next step is I'm going to create another one. So this one is basically running almost the same thing. So all the commands here, basically the same. I'm not going to explain all of them again because we're almost running out of time. So because the idea here is to have two containers, right? And one communicating to each other. So I'm calling this node 2. Okay, host node 2, mounting the proc the same way. I'm gonna create the oops. This is I need to run from outside. Remember that I said that would be good, would be very important to have more shells. Yeah, this is the moment that we need more shells. Let me just double check one thing here. On the network, here we are using 192.168.22, and the other one is was 192. Okay, so we are in the right network. So okay, so everything looks fine so far. Let me just run here. Okay, no error. Let's see if we ping. We are able to ping. So it means the container works fine. The same thing for the Cgroups. We want to limit them. This was a test. I don't need it. And so those I don't need anymore. And okay, we have the container here. This is, we can go back to the node 2. Remember, this is the container node 2. Okay, and I'm gonna do the same on the container node 2, right? So I'm gonna run apt update. I'm gonna install the Vim and the Postgres. But one thing here, I'm gonna remove the main folder because this is gonna be a replica, right? It's not a primary database. It's gonna be a replica replicating for the other database. And are our containers able to communicate to each other? Are we in the same network? Let's find it out. So it's taking longer than I was expecting. Okay. So I'm gonna remove, and this is the moment. Remember, this is the other container IP. So do I have IP comment here? No, we don't have IP comment here, but we have outside. So I can just execute. And D2, it's the name of that one. So this is the IP of the container queue, and this is the IP of the container one. So the container queue, this one, gonna be a replica of the container queue, right? Let's go back to the node queue. Let me go back here. Let's run this pgback rest command here. And we hope that everything will work well. Well, we have a problem. Well, that was really fast. Oh, of course, it's asking for my password. How stupid I am. Okay, yeah, it's doing the backup. Well, it's a good sign. It's taking some time. And it should not take too long because we're inside of the same box, right? Just wait here a couple of seconds. And well, while it's backing up here, so from what we have here, what would be the next steps? The next steps would be to have another server. So we could put another node, or what they call in Kubernetes pods. So now here I'm working inside of one pod. As we can see here, all the basement, all the foundations of how containers work, they are inside of the Linux kernel. So everything else, everything that Dockers and LXC, all those guys, they do, is to use the underlying infrastructure that we already have. And remember when I said that the analogy of a lightweight virtual machine for a container, it's not coherent, it's not really true, because it's not a virtual machine. We are still inside of the same box. There's no really that strong isolation. So what we do here is we create namespaces to isolate the applications, to isolate things. Oh, it's waiting for checkpoint to never finish here. Okay, now it's backing up. So all those isolations here, they're done for the namespace and capability that the kernel has, right? And then we have the restrictions for all the other things, for Cgroups, and so all those together are what we call a container. There is literally nothing so special. Like it's amazing how it works. It is amazing how it works, and it's amazing to understand how those things work. It's super amazing. But so everything is there already, right? And it's important that you understand how those things work, so you can decide that if it makes sense for you to use on your database, or if it's going to be harmful. There are a lot of applications, there are a lot of customers that make a lot of sense for them to run inside of containers or to run inside of Kubernetes. But for other situations, there are also a lot of situations that it makes more harm than good to run inside of containers or run inside of the Kubernetes. All the orchestration that Kubernetes gives and things, they're amazing. But for the other side, they also needs a lot of investment in time and training for the team for all those kind of things. They are not easy. They are not simple. As you can see here, there are so many pieces put together to make those things work. And when a problem happens, it can be a nightmare to find where a problem happens. So we really need to understand those things. This is what my message for today is. Really need to understand how those things works. So then we can decide how we can move on. And I really hope that was useful. Okay. Well, of course I don't have the table T2, right? But I should have the table T1. Yeah, it's just replicated from the table T1. And let's give a try. Let's create a table T2. Create. Oops, come on. Nope. Okay, I have it here. Create table T2. I love how sometimes things work. I want to be lazy and it just doesn't work. Let me change here. I have it just here. So, okay, create the table. I'm going to insert the table T2, but instead of 1 million rows, I'm going to insert just 300,000. So it should be enough. So I inserted 300,000 holes. If we go for the other one, now we should have the table T2. Yeah. And here we have 2 containers running inside of our box. And inside of each container, we have a Postgres running, and we have a replication between them. So I can call it's a success, right? So yeah, that's it for today. I hope you enjoyed, and I hope that was useful for you. I hope you learned some things. And it's bad that Dave cannot, I cannot hear Dave. But well, that was great. Oh, thanks for your time, and have a great day.